for this experiment. Introduction.
Ice is a common name for sodium acetate trihydrate. It's a chemical that can be supercooled in liquid form and then triggered to crystallize instantly, releasing heat, hence the name hot ice.
Solubility.
So solubility is the ability of a solid to dissolve into another substance. The higher the temperature of the substance means that it will have a higher solubility. When it boiling means that it will be saturated at high temperature, which makes it supersaturated at a lower temperature, which results in excess sodium acetate. That means sodium acetate is considered the solution is considered metastable as it has excess sodium acetate and will start to crystallize with external disturbances, and also known as force, and or introduce a seed crystal, which is sodium acetate solid.
Methodology and material.
So first, you must mix vinegar and baking soda constantly, and you must add the baking soda once the thing stops freezing. 2. Boil the solution for 1 hour until crystals start to form on the edges. 3. Pour the solution into a cup or bowl until it cools down. 4. Scrape off the sodium acetate crystals to use later. And 5. Once the solution has cooled down, you can add a little of the crystals into a plate, and you can add the solution to it, and a towel will form.
So in this experiment, the materials needed will include a pot, a stove, baking soda, vinegar, and a bowl to store the sodium acetate solution. But as an alternative to the stove, you can also use a rice cooker to make the solution.
Periodic trend.
Ionization energy is the minimum amount of energy required to remove an electron from an atom. So as you go up a group and across the periods, the ionization energy increases. So you could say that the ionization energy increases in a linear path in this direction. And atomic radius is referring to the size of an atom, specifically from the nucleus to the valence shell. So the opposite trend is true for the atomic radius. As you go down a group and this way across from a period, the atomic radius increases. So it increases in the opposite linear direction.
Electronegativity.
So another key concept in this experiment is electronegativity, which determines the ionic nature of sodium acetate. Sodium and oxygen forms an ionic bond in which sodium loses its electron and oxygen gains the electron from sodium, which forms sodium acetate, and this is the chemical formula for sodium acetate. Electronegativity also causes the water polarity that results in the ability for the water to dissolve sodium acetate as an ion. Oxygen, in the formula H2O, oxygen attracts the shared electron in the water, forming a water molecule with polar ends, one positive and one negative. So the trend of electronegativity in the periodic table is that it decreases down a group and increases across a period. The definition of electronegativity is the tendency for an atom to attract an electron in a chemical bond, and this is due to the difference in atomic radiuses between the different elements. Okay, so electronegativity also causes the ion-dipole interaction between water and the sodium acetate. So the polar ends of the water molecule will attract the fully charged ions of sodium acetate. The negatively charged side of hydrogen will attract the fully charged a positively charged sodium ion, and the positive side of oxygen will attract the negative part of sodium acetate.
To relation to other fields of science.
So now that we know what the hot ice experiment is, we also should understand how it's related to other fields of science. Well, to start off, the hot ice experiment is mainly a chemistry experiment. However, you can link it to physics and physical chemistry. This is mainly because the main concept of the hot ice experiment is based on an exothermic reaction, which is caused by exposing vinegar and baking soda together, which forms sodium acetate in a crystallized form. Crystallization is a process where a substance or solution changes its state of matter and forms into a rigid crystalline structure. And in this structure, the smallest unit is a unit cell, which acts sort of like a semi-permeable membrane, which allows some things in and other things no. So at this stage, the sodium acetate is considered a metastable solution, and it is also supersaturated and will not change unless there's a perturbation. However, in some cases there might be some excess solute, and the sodium acetate will precipitate out that excess solute, which leads to crystallization. Exothermic reactions are a key concept of thermodynamics and are a process where a solution or a substance releases heat. Thermodynamics are a key branch of physics, and they study topics such as work, heat, temperature, energy, radiation, and other related topics. And therefore, this is the main connecting factor between chemistry and physics in this experiment.
Conclusion.
Now we know how the hot ice experiment is linked to other fields of science, and mainly physics. So it's mainly linked to physics through thermodynamics and crystallization, which are key concepts of physics and what the experiment mainly relies upon, except for the other factors such as the materials and process, which is mainly a chemistry based.
Thank you guys for watching.